Good day and welcome to this video of fluid mechanics again. And in this part we are going to be calculating capillary effects. So calculating the capillary effect in millimeter in a glass tube of 4 millimeter diameter. That will be giving us the millimeter, the diameter. So I think we should start noting as we are reading along. So distance is 4 millimeter. Diameter is 4 millimeter already. So we change this one to meter as usual. So that will be 4 times 10 raised to power minus 3 meter. And let's read. When immersed in water and mercury. So we are dealing with two different liquids. We are dealing with water and mercury. So the temperature of this liquid is 20 degrees Celsius. So they are giving us the temperature as 20 degrees Celsius and the value of the surface tension of water and mercury. Here we are dealing with surface tension. We have surface tension. So surface tension for water is 0.07575, and they also give us surface tension for mercury, so that is 0.51. So for mercury 0.51, they are in Newton per meter. It's force over weight. So now whatever they are giving us now, so let us know the remaining one. So we have the angle of contact for water and also for mercury. The angle of contact for water is, so the angle of contact for water is 0 degree, 0 degree. Then the angle of contact for mercury is 130, and they gave us density of water finally as 9 point. The density that we are going to be using of water as 20 degrees Celsius. They've given us in question before. So here, when calculating for capillary effect, we have the formula. That is, we have the capillary effect equals to 4 the shear stress, 4 multiplied by the shear stress, then cos the angle of contact divided by WD. So what is that W that is there? We are going to be calculating the weight, the specific weight, and since we have the density here, we can calculate the specific weight. Remember that specific weight is weight over volume. So and what is weight? Weight is mg over v. From here we can take our density from here, which is mass over volume. So you will have g, which is density multiplied by gravity. I know that we have been given, gravity as 9.81, so we can just multiply it by our density to get our weight. So that will be our density here is 998, then multiply by 9.81. So that will be our density. That will be our weight rather. What will be our weight there? That should be 9,719.38 Newton, as Newton per meter cube. So now we are going to be calculating for water and for mercury. So the effect for water and the effect for mercury. So let's go calculating for water now. We're calculating H of water. That is the capillary effect of water. Using that formula, this formula, we are going to be having 4. So what is the shear stress of water? This is it here. So we bring it to, we have 0.073575. Then cos the angle. The angle of contact for water is 0. So our cos 0 is equals to 1. So let's put it there. It doesn't mean. So our weight here, we've gotten our weight. We calculated it before. So we got it as 9790.38, and multiplied by the diameter. And they are giving us diameter in question as this. So it remains for us to calculate this value. So when you calculate that, you are going to be getting 7.52. It's 515, but 52 times 10 raised to power minus 3. This is in meter. And remember, we are asked to calculate the effect in millimeter. And you know millimeter is times 10 raised to power minus 3. So when you multiply, when you want to change this to millimeter, it's going to be times 10 raised to power 3. And in that we cancel this. So your answer will be 7.52 millimeter. That's for water. This is the normal capillary effect for water. Now, if you want to calculate for mercury now. So for mercury now, using the same formula, we are going to be having 4. But remember that the stress of mercury has its own stress, which is 0.51. So you put it 0.51, and your cos, your angle of contact for mercury is 130. So put 130 there. We have to note these important parameters. Then your weight, our weight is still remain the same because they are sharing the same weight. So that will be 9790.38, and multiplied by the diameter still remains 4 times 10 raised to power minus 3. The only thing that changed there is the stress and the angle of contact for both entities. So at the end of the day, when we calculate that, you are going to be having a minus. So when you are getting minus, do not be discouraged. It's a sign that capillary is a depressed one. So instead of it to make a parabola path on top of the surface of the liquid, it is doing it in the opposite way. So you are going to be having minus 0.033 minus 0.0335. So this is in meter. So we are asked to change it to millimeter, and that will be times 10 raised to power 3. Note, if it is in millimeter and you want to change it back to meter, that will be times 10 raised to power minus 3. But if it's in meter and you are changing to millimeter, that will be times 10 raised to power 3. When you do this times 10 raised to power 3, what are you going to be having? You are going to be having, you can just count 1, 2, 3. So it's going to be minus 33.5 millimeter. So that is the capillary effect of the mercury. Remember, one for the water that we got the other time, so 7.52 times 10 times 10. Okay, we later convert it times 10 raised to power minus 3, and later converted it to millimeter. 7.52 millimeter. So this is for the water, this is for the mercury. Thank you very much. Like, share, subscribe, comment. This is the end of this video. We are going to be releasing more videos on tube mechanics this season.